guys. Welcome to today's lesson on relations and functions. This is the second lesson of Unit 3. Our Unit 3 is linear relationships. So because this is the second lesson, make sure that before you do this lesson, you have completed the first lesson in Unit 3, which is coordinate plane basics. Before we get started, if you would please go into the course and then course content and then Unit 3 and then the relations and functions lesson and print out the note guide. Okay, for this lesson there are lots of vocabulary words, and if you have your note guide right in front of you that you can take notes on, it's going to make that note taking a lot easier for you. So right now, if you haven't done that yet, please print out your note guide and we will go ahead and get started. So, like I said, this lesson does have a lot of vocabulary words associated with it. And so the very first thing that I want you to do is, if you don't have your note guide, you need to push pause on your video and write down all of these words. We are going to be working on defining these words in today's lesson. Okay, we probably won't get to the vertical line test. This lesson is probably going to take us 2 days. So we'll do part 1 today and part 1 tomorrow. So let's start with the first 4 words: set, element, finite, and infinite. So again, if you need to pause your video and write down the definitions for these, please do that. So pause your video and then push play when you're ready to move forward. A set is a collection of objects. An element is one item in a set. If there is a limited number of elements, we call this finite. Okay, so if you can list all of the elements, if you can count the elements, if there is an end to the number of elements that there are, we call this finite. If there is an unlimited number of elements, we call this infinite. Okay? So up here on the screen, I have a picture of a set. This is a set of drums. Okay, so this would be considered one set. It's a set of drums. Each different part of this set would be considered an element of the set. Okay, and I wish I was a drummer so that I could tell you what all of the names of these parts are of this drum set, but I'm not. I do know that this one is cymbals, I think. I think it's cymbals. And so this set would be finite. Okay, it's finite because we can list all of the different elements. We can go through and we can actually list these different parts of the set. Okay, so that makes it finite. Let's look at another image. This is an image of a set. This is an image of a set of books. Okay, each book in this set is an element of the set. And this set is finite because we can actually list the elements. We can count how many books there are in this set. There is an end to the number of books that there are. Okay, so this is an example of a set that would be finite. Okay, here we have another set. This is a T set. Each of the different pieces of this T set would be considered an element of the set. Okay, so as we look through here, we can actually even count the elements in this set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be finite. This set would be finite. Okay. Now, for the next one, you've been given an image to look at. That is an image of all of the integers. So remember that integers are positive and negative whole numbers. What I want you to notice here, when we think about integers and our number line, this arrow right here means that this number line is going to go on forever and ever and ever in that direction. This arrow right here means that this number line is going to go on forever and ever and ever in that direction. Okay, so this is a set of integers. Each different integer would be considered an element. This set would be considered infinite. Okay, and the reason that it's considered infinite is because it doesn't have an end. We can't count the number of elements in this set because they're always increasing in both directions. Okay. Another example of an infinite set that I just thought of was the number of stars in the sky. If we think about the sky being a set and the stars being elements of that set, that would be an infinite set. Okay, because we can't count or list. I mean, it goes on forever, right? Okay, so far in our notes, we have talked about what it means to be a set. We've talked about what it means to be an element. We've talked about finite, and we've talked about infinite. For the next part of our notes, we are going to talk about relation, domain, and range. Okay, so I want you to write down this paragraph in your notes. It says a relation is a relationship between sets of values. In math, the relation is between the x values and the y values of ordered pairs. Okay, so that's an important thing. The relation is between the x values and y values of ordered pairs. The set of all x values is called the domain, and the set of all y values is called the range. So if you need to take a minute to write this definition down, pause your video, and then push play when you're ready to move forward. There are different ways that we can represent relations. Okay, so if we have this relation, which is this set of ordered pairs, okay, the x and the y values are elements of this set. The domain is the x values and the range is the y values. Okay, so if we go through this set of ordered pairs, we know that ordered pairs are listed x first and then the y. Okay, so for this set of ordered pairs, our x values would be -9, -5, 1, and 7. 7 twice. Actually, we don't need to list that twice. So our domain would be -9, -5, 1, and 7. And if I want to write that as a set, I'm going to go ahead and just do that. So if we write the domain as a set, the elements that would be included in that set would be -9, -5, 1, and 7. Okay. Our range for this relation would be our y values. So 1, 5, 8, 1 again, and 4. So if we want to write the range as a set, the elements of that set would be 1, 5, 8, 1 again, and 4. Okay, so this is the domain and range of this set of ordered pairs. Okay, so remember, domain is the x values, the range is the y values. So that's one way to represent a relation, is a set of ordered pairs. Another way to represent a relation is by using an arrow diagram. Okay, in this arrow diagram, these values right here are considered our inputs, and these values right here are considered our outputs. Okay, these are our x values, and these are our y values. So our x values are our inputs, and our y values are our outputs. So this arrow diagram is made up of this set of ordered pairs. It's just represented differently. Okay, we can see that -9 is paired with 1. We can see that -5 is paired with 5. We can see that 1 is paired with 8. And we can see that 7, I'm going to circle that with a different color because this is something we're going to talk about a little bit later. But we can see that 7 is paired with both 1 and it's paired with 4. Okay? And we can see that in this when it's listed as a set of ordered pairs too, right? That the number 7 is paired with more than one y value. Okay, so an arrow diagram, that just gives us another way of representing a relation. Now, we know that we already listed the domain for this relation. Okay, let's go ahead and look at the table. Let's talk about some things in this table. The table is just another way to represent this relation or this set of ordered pairs. We can see in our table we have -9, 1, -5, 5, 1, 8, 7, 1, and 1, 4. Okay, and then another way to represent this relation is to actually graph the relation. Okay, so to plot the points for each of these ordered pairs. So as we look through here, we have -9, 1, we have -5, 5, we have 1, 8, and then I want you to notice here we have 7, 1, and we have 7, 4. So when we look at it as a graph, it's easy to see that the 7 is paired with both 1 and 4. Okay, so now let's go through a few more examples. You have 3 different examples here. For each of these examples, we need to state the domain and range for each relation. So let's start with number 1. Number 1, we have a set of ordered pairs here. Remember, ordered pairs are listed x first and then the y. Okay, and our instructions say to state the domain and the range for each relation. Okay, well that's easy. We can do that. We know that the domain is the set of all of the x values, and the range is the set of all of the y values. Okay, so our domain consists of 100, 120, 140, 160, and 180. Okay, and one thing I want you to notice here is that for our domain, all of the x values are different. Okay, we don't have an x value that's repeated in this set more than once. Okay, so each of our x values is paired with a different y value. Okay. So let's go ahead and list the range. So the range would be 5. And 5 is actually listed twice, but we're not going to list it twice here in our range. 6 is listed twice, and 12. Okay, so that is our domain and range for question number 1. Let's look at question number 2. So question number 2 is an arrow diagram. I'm going to go ahead and just write these also as a set of ordered pairs. 3, -6, -2, -1, negative 1, 0. I have no idea why that says negative 0. That shouldn't be there, okay? 0 is negative, neither positive or negative. And then we have 0, 3. Now, this is important for you to realize, okay? 1 is being paired with both 0. Oh, I wrote that backwards. I wanted to write a 1 first. So 1, 0. And 1 is also being paired with 15. Okay? So here are our x values. Remember, these are our inputs. Here are our y values, which are our outputs. Okay, so if we want to list the domain, so this is question number 1. I'm going to put question number 2 right here. So our domain, move this over here. So our domain is negative 3, negative 2, negative 1, 0, and 1. Negative 3, negative 2, negative 1, 0, and 1. Okay, so there's our domain. Our range is negative 6, negative 1, 0, 3, and 15. Okay, so that is our domain and range for this relation, number 2. Okay, let's go ahead and look at number 3. I actually am going to snip this and put it on another page so we have some more space. So for number 3, we need to do the domain and range for this relation. So in order to do that, let's just go ahead and list the ordered pairs for each of these points. So right here we have negative 4, 1. So to the left 4 and up 1. For this one, we have negative 2, 2. For this one, we have 2, negative 2. For this one, we have 3, 1. For this one, we have 3, 4. Okay, so here are all of the ordered pairs of these points. And if we want to list the domain and the range, our domain is all of our x values and our range is all of our y values. So the set of our x values are negative 4, negative 2, 2, and 3. Our range is 1, 2, negative 2, and 4. Okay, so that's our range. One thing I want you to notice here is as we look through our x values, can you see that the number 3 right here, this x value of 3 is being paired with more than one y value? So if I were to do this as an arrow diagram, negative 4, negative 2, 2, 3, and 1, 2, negative 2, 4, okay? Negative 4 would pair with 1, negative 2 would pair with 2, 2 would pair with negative 2, 3 would pair with 1, and 3 would pair with 4. Okay, so can you see how this 3 is being paired with 2 different y values? That's going to be important as we move forward in our lesson. Okay, so domain are our x values, range are our y values, and let's go ahead and move forward. Okay, so let's go back to our list. Now we can cross off relation, we can cross off domain, we can cross off range, and the last thing that we're going to talk about today is a function, what it means to be a function. Okay, so a function is a special relationship where each input, remember our input are our x values, okay, has a single output. Remember, our output are our y values. So if you need to take a second and pause the video to get this written down, do so. And then go ahead and push play when you're ready to start again. Every function is a relation, but not every relation is a function. Okay, so that's a pretty important thing to know. Every function is a relation, but not every relation is a function. The only time a relation is a function is if each input has a single output. So let's go back to some of the examples that we looked at earlier. I want you to look at this example right here, this arrow diagram. Okay, and remember I circled this one in green and I said we were going to come back to it. Okay, can you see that this 7 or this input is paired with two different outputs? So this would not be a function. Okay, that's an example of something that's not a function. For another one of our examples right here, can you see these ones I circled in blue? Okay, for these inputs right here, we have the number 3 being paired with 1, and 3 is also being paired with 4. Okay, and it's really easy to see it with an arrow diagram. So that would not be a function. So let's look at a few more examples here, and let's just figure out if these would be functions or not functions. Okay, so the best thing to do is this is our inputs, this is our outputs. Okay, remember the x values are our domain and our inputs. The y values are our range and our outputs. Okay, so if we are trying to determine whether this is a function, all of our inputs have to be paired with a single output. So every x has to be paired with a single y. If you have an x that's paired with more than one y or a different y, then it is not a function. Okay, so let's go through our list. We have -3, that's being paired with 3, so that is 1 to 1. We have -2 being paired with -6, that's 1 to 1. We have -1 being paired with 0, so that's 1 to 1. We have 0 being paired to 15, so that is 1 to 1. And we have a 1 being paired with -1. So in this relation, we don't have any of our x values that are being paired with more than one y value. So we would say yes, this one is a function. Okay, let's look at the next one. Here are our x values, here are our y values. 3 is being paired with -6. -2 is being paired with -1. -1 is being paired with 0. 0 is being paired with 3. Okay, look very carefully here. This is a big clue. We have 1 being paired with 0, and 1 is also being paired with 15. So because we have one of our inputs that is being paired with two different outputs, can you see that? We have this one input that's being paired with two different outputs, then we would say this is not a function. Not a function. Okay, let's look at the next one. We have 6. So here's our x values or our range. Here's our y values. So 6 is being paired with 2. -1 is being paired with -1. So far we're 1 to 1. 1 is being paired with 4. Okay, still 1 to 1. 5 is being paired with 4. Okay, so 1 and 5, those are two different x values being paired with the same y value. And when we're talking about functions, that doesn't matter. Two different x values can be paired with the same y value. You just can't have one x value being paired with two different y values. Okay, and then 7 is being paired with -4. So we would say, yes, indeed, this is a function. Okay, because each of our x values is being paired with a different y value. Okay, you guys, you did it. You finished the lesson. I always try and keep these under 25 minutes, and right now we are at 24 minutes and 49 seconds. So here's your quiz. Remember that for this lesson, you need to turn in both your notes and your quiz. I am going to go over what I want you to do for the quiz just to make sure that you understand. For question number 1, you are to list the set of ordered pairs included in this relation. So you've been given a relation here, okay? These are your x values, these are your y values. You need to take this arrow diagram and you need to list out the ordered pairs. Okay, so you're going to represent it as a list of ordered pairs. After you have done that, you are going to list the domain and the range of the relation. And then for number 3, is this relation a function? So I'm looking for a yes or no. And then you also have to have, how do you know? So not just a yes or no, but how do you know? Okay. If you've gotten through this lesson and you still have questions and you are not quite sure about some of these vocabulary words, you can come to Math Lab. Math Lab is every day, Tuesdays, Wednesdays, and Thursdays from 3 to 5. Or you can also make sure and come to class. You guys, I do these lessons live in class. Okay, so come to class and do the lesson there. Do the lesson, get your quiz done. The very best way for you to be successful in this class is to come to class. Okay, so with that said, if you're a student who's working behind, get caught up. Get caught up, come to class. Miss Kohler and I are really happy to help you. All the time we want to help you and help you to be successful. So with that said, you guys go ahead and get this turned in and have an awesome day, and we will hopefully see you soon.